Ladies and gentlemen, good day and welcome to another session of Digital Revision Program. Like I said, this is intended to support each and every learner who's doing technical sciences, either in the Free State or in South Africa generally, because we try to multiply and we have platforms where you can easily access this. We are now live also on YouTube, but please note that even if you watch the video later, kindly complete the register for us. That will assist us now in order of tracking the numbers and the impact of the program as well. Ladies and gentlemen, this is the second edition for November revision program. We did have one session yesterday and Newton's laws, momentum and impulse. So the video is readily available on Nambani Academy on the YouTube, and the e-notes were distributed now to relevant teachers through our WhatsApp groups. So we are only just trying to assist. Ladies and gentlemen, without wasting any time, we intend on doing elasticity and hydraulics for today. I intend finishing off the session in at least a maximum of 45 minutes, but obviously that will be now regulated by the flow of how things go. With that being said, majority of us will ask ourselves, why elasticity and hydraulics? It is one concept, ladies and gentlemen, or two concepts that I feel that each and every one of us as learners must be able to get maximum marks. Because when you look into it, it's only based on critical definitions as well as the application of certain formulas. So I thought it will be quick and easy way for us just to have a quick recap on basically what is elasticity and what is now hydraulics. Ladies and gentlemen, allow me to have a column here where I will differentiate or use it in order for me to explain the difference between the two. This side I'm going to have my elasticity, and this side I'm going to have my hydraulics. Key thing is one must now try to understand what is the difference between the two. The difference between the two is hydraulics is just the study of mechanical properties of liquid. So let me just write it down: study of mechanical properties of liquids. So what does this say to us? It says somehow we will be focusing on how best or effectively can one be able to use the liquid or the properties of the liquid thereof. However, elasticity is defined now as the property of the body. The property of a body by virtue of which the body regains its original shape. Original shape and size. And size when the deforming force is removed. ladies and gentlemen, this is one of the critical definitions that one must know, because the expectation is define what is elasticity. So elasticity is the property of a body by virtue of which the body regains its original shape as well as size when the force or the deforming force is removed. But what does this say to me? It says this particular object or this body, I can only prolong it or change it to a certain maximum, and then that certain maximum is what we call now elastic limit. So the elastic limit, it is just now what? The maximum force that can be applied to a body. So this will be now the maximum force that can be applied to a body so that the body regains its position. The body regains its shape, and size. You will get other definitions or books where they say just it regains its original form completely when the force is removed. When a force is removed. But now this says, okay, fine. How will this now assist me in an exam? Ladies and gentlemen, this will assist me in an exam to understand that in actual sense, when we talk of the maximum force applied, we are actually referring now to a force that will also give us a reading, or that will also give us a reading of what we call a restoring force. So these are key definitions that one must be able to understand. But there are now things that are coming also playing a part, especially under hydraulics. So under the hydraulics, ladies and gentlemen, when we have an elastic limit, for the hydraulics we have what we call now pressure. And now this pressure, ladies and gentlemen, is what we call the force acting per unit area. So this is now the force acting per unit area. A new concept is being introduced, the concept now of area. Now what does this mean? It says, ladies and gentlemen, I should be now either from the previous sessions or either from the previous lessons, I should be able to calculate either an area of a circle or also a area of a rectangle. Ladies and gentlemen, if this is the case, that will say to me, fine, then I must be able to say area is equals to pi squared r, and area here is just now length multiply by breadth. But what does this mean when I am working with hydraulics? Whichever way, the way we calculate for area will also be applicable, ladies and gentlemen, for the calculations of elasticity. So area is one common calculation that will now either be using for elasticity as well as now the hydraulics. Remember, the formula sheet will be given, but the two equations of how to calculate the area of a circle, how to calculate the area of a rectangle will not be provided. I don't want to complicate the science. If you are given a circle and you must work with that, just ensure that you work with a radius, not a diameter. Why? Because remember, in an exam, and it's one of the formulas that you must memorize. So I cannot give you a lot of formulas, the one with the 4d squared and something like that. Let's just remember that radius is just now what? Half of the diameter itself. So if I have an area or a circle, I must just get the radius and it will be easy for me to understand. But the very same pressure for hydraulics, it can be a pressure of a liquid, or it can either be a pressure on any surface. The formulas, ladies and gentlemen, will be P is equals to F over A, where the area now comes in, and then P is equals to P G H. Why do they differ? They differ, ladies and gentlemen, because of a new factor here that we call density. So a new factor which we call density, it's the one that is influencing the difference in the two equations thereof. Very, very, very important. But now, we need to also be in a position of saying, if we have density, is there a correct way or an important way of remembering this? Pressure is measured in pascals. Then we just say for P, small p, we just have it as density, and then this is kg per meter cubed. This is now the first two equations that we are going to need. So if it has anything to do with pressure, please note that you will need to use one of the two equations in order for you to perform a calculation. But the challenge will be, am I working on any surface or am I working with a liquid? Then if you are working with a liquid, it is important, ladies and gentlemen, to use now the correct formula. I said I'm going to combine and intertwine the two. Why? With the link of saying I need few things of hydraulics to assist me with elasticity, or I might just need few things of elasticity to assist me with now hydraulics, because this is a final exam. The integration of topics is very, very key. Don't expect to have one question separate for elasticity and then one question separate now for hydraulics. What we do is the integration of topics is what we expect to see on Friday. Let's look into elasticity. Two critical things that one must now try to understand is what they call Hooke's law, and for hydraulics we work now with the Pascal law. We work with the Pascal law. So you will be expected, ladies and gentlemen, to define or state either one of the two. So for Hooke's law, it is very easy. We just say within the limit of elasticity, the limit of elasticity, stress is directly proportional to strain. Let's immediately go into now the Pascal law. It says in a continuous equilibrium, a continuous liquid at equilibrium, liquid at equilibrium, the pressure applied at a point, a pressure applied at a point is transmitted equally, to other parts of the liquid, equally to other parts of the liquid. Is it possible to assign any form of an equation to these two laws? Because yesterday we spoke about the SUA, state, use and apply. Will we now be in a position of applying the two laws in a sense that if I am asked or given to state, will I be able to use and apply? Yes, I should be able to do so, because the formula for this here will be K is equals to mu over E. Let me just write this one the right way. Much better. Fine. And for Pascal law, I'm going to now use F1 over F2 is equals to A1 over A2. Whichever way, some people will write F1 over F1 and F2 over F2. Whichever way, it doesn't necessarily influence the answer. But let's check the one that will be given in the formula sheet. Ladies and gentlemen, now comes new two concepts. Within the limit of elasticity, stress is directly proportional to strain. So we call this one stress and we call this one now strain. The unit of stress is Pascal as the pressure. The unit of strain is that it does not have any units. The concepts are becoming now more clearer and clearer. It means I should have an equation that will assist me to calculate for stress. But I already have an equation from hydraulics which says P is equals to F over A. So how about saying stress is actually F over A, which will be now the internal restoring force per unit of a body. So everything here will link now with the pressure of the hydraulics, where F is the force in newtons and then A is the cross-sectional area. Now the A must be in square meters and then F must be now in newtons. Hence I said A will be influenced by which body are you referring to. Are you working with a circle or are you working with a rectangle? So either way, either for elasticity or hydraulics, we will need to get now the area that is needed of the object or the body that we are working with. It is a quick recap. However, we need to understand the link between the two. Furthermore, there's now an introduction of the strain. The strain is measured as changing L over L, where L is just the extension in meters, and then L is just the original length. Ladies and gentlemen, what does this say to me? It says to me, once the body has been stretched to its maximum, once the body has reached its maximum elastic limit, or that maximum force that can be applied so that the body regains its shape, it means it will extend in certain number of meters or even smaller number of dimensions thereof. So we will need that in order for us to calculate what we call the modulus of elasticity. So this we call now modulus of elasticity. Modulus of elasticity. Ladies and gentlemen, these are now three important equations that we all need to understand how they work. But let's check what is the catch here. The catch is, we recently spoke that strain does not have the SI unit. So what does this say here? It says change in L and L must be in the same SI unit. Same SI unit. What does that mean? You can only work with meters and meters. You can only work with centimeters. You can only work with meters to meters. What is important is that the SI units must be the same. Once the SI units are not the same, you are going to get an incorrect value of strain, and once you have now an incorrect value of strain, ladies and gentlemen, you are going to get now an incorrect SI unit of what? Of the modulus of elasticity. And the modulus of elasticity, we measure it now in also Pascal. Why Pascal? Because stress is in Pascal and the strain does not have now an SI unit. I am not going to bore you with basic principles of conversion. 1 kilopascal is equals to 1000 Pascal. Rule of thumb is area must be now in the same SI unit. force must also be in the same SI unit, which is now newtons, for us to be able to apply this in detail. Furthermore, all other things are the application and stating the differences between each one of them. But what is important is with calculation, with definitions, these are the most important ones that I feel and believe that once we can be able to differentiate between the two, then we will be in a good position to perform well. However, ladies and gentlemen, we still need to understand the following important definitions. So these are now important definitions. The ones that I did not mention, but they are critical for each and every one of us to note, because anything and everything is possible. The very first one is now, what is a deforming force? Very, very important. B, what is now perfect elastic body? Perfect elastic body. C, perfect plastic body, or perfectly elastic, and then perfectly plastic body. So this, ladies and gentlemen, are other definitions that you must now be in a position of at least writing the correct definition, because anything, it is very, very important. Plasticity, and then restoring force. Ladies and gentlemen, these ones are important. There will actually be 2 marks, not plus or minus. 2 marks. These are now the ones that are based on elasticity. Do we have any other one that we might maybe worry about when we talk hydraulics? For hydraulics, ladies and gentlemen, I am going to have A. The most important one is what we call thrust. What is thrust? Is just the normal force exerted by a liquid at rest on a given surface in contact with it. But remember, all these definitions are available in our exam guidelines, in the terms and definitions that we have done. This is now the most important one. Maybe we can add also to say you'll be somehow expected to also define what is a density. So ladies and gentlemen, all these are definitions that we need to know. However, I said I feel that these ones are the most important ones. Why are they most important ones? Because they will assist us in applying the SUA that we spoke about. So ask a definition, state the law, use that and apply. And if I am going to apply, remember we said this will be now for life scenarios there. Scenarios. And this, it will be the use, that is now the application as well as the calculations, and the S will just be for stating. So how and why should I ask you to define something of thrust, whereas I am not expecting you to use the equations related to that? Rather, let me ask you Pascal law for you to give me the calculations. Rather, let me ask you the pressure for you to perform a calculation of a liquid of pressure, the pressure of a liquid, as well as now the pressure on the surface. Rather, let me give you the elastic limit, elasticity, or Hooke's law in order for you to perform the calculation of strain, the calculation of stress, and also the modulus of elasticity. So this here, it is what I call a way of winning the exam, with the sense that somehow you must use the calculations thereof. Ladies and gentlemen, once these are done, and before we can get into maybe an example thereof, let's get our 50 seconds of what we call, let's digest the slide, let's digest everything that is here, drink water, and then be back in the next 50 seconds. If there are any questions, maybe also send the questions in the chat, and then I will be able to try and assist with that. Ladies and gentlemen, I do not see any hand or comments in the chat, so it basically says we can go ahead and continue. Now, after this nice and easy summary of how to link the two, it will be best now to say, let's have a previous paper just to try and assist us in terms of ensuring that we actually understand what we actually mean with elasticity as well as hydraulics. Ladies and gentlemen, these two combined will give us plus minus 23 marks in an exam. But where is the 23 marks? And how best can one be possible to say, how do I get maximum of each and every one of them? How do I get to my minimum of 70% in this section if things are very complex? Ladies and gentlemen, 6 marks already. It is based on what we call level 1 question, which is just the definition. Because the question of saying distinguish between perfectly plastic body and perfectly elastic body, it is actually saying define perfectly elastic, define perfectly plastic. That is what the question is basically saying. So already stating Hooke's law will also give us now that 2 marks. So already I am somehow very close into getting the 60% that I want into now this section. Ladies and gentlemen, let me quickly now try and answer these questions for you. So at 5.1, let me have a divider also and just say this one will be perfectly plastic and perfectly plastic. Let's go. Perfectly plastic, a body does not show any tendencies to to regain strength. A body which does not show a tendency to regain to regain its original size, and shape, comma, when the deforming force is removed. The deforming force is removed. Because it's a definition, ladies and gentlemen, it will give us the 2 marks. Now, perfectly elastic, a body which regains its original position. A body which regains its original shape, and size when the deforming body is removed, when the deforming force is removed. So the examiner of this paper was actually in simple terms asking 2 definitions of what is perfectly plastic body and what is now perfectly elastic body. So because when, like I said, when you look into it, the calculations are predictable. The calculations of the information given will always be calculating the strain, the stress, the modulus of elasticity. With hydraulics is the application of Pascal law, also calculating for the pressure of the liquid as well as now of the surface. So when you check, majority of the questions, ladies and gentlemen, will come from the definitions. When it gets to application, it will always be 2 marks, 1 mark, but the important parts is us knowing all the critical definitions thereof. Hooke's law, I am not going to state Hooke's law for the purpose of we explained that in the previous slide. So Hooke's law, ladies and gentlemen, it just says within the limit of elasticity, stress is directly proportional to strain. So for the purpose of time, this was already done. Ladies and gentlemen, let's check this. State, use, and apply. Stating Hooke's law, it says application thereof of the Hooke's law. Use now of Hooke's law. But let's see. Calculate now the strain on the steel railroad. The very first thing, it is 4 marks. For me to write the correct formula, I will be very, very happy because already I will be having that 1 mark. So strain, ladies and gentlemen, at 531, strain is equals to changing L over L. Then I can easily go and say a steel railroad track is 100 meters long. When its temperature is raised, the length of the track increases by 0.2 centimeters. So now we have a problem here, ladies and gentlemen. What is the problem? The length, or L, is in meters, but now the change is in centimeters. So what must one do? Either you convert centimeter to meter or meter to centimeter. The answer will still be the same. but just say now in this instance know how to go about converting in terms of your length. So I'm just going to say, for me, I want to work with meters because meters is easy for me to use. I am just going to say, okay, fine. If I want to convert centimeter to meters, centimeter to meters, I must now divide by 100. Then this will become 0, 0,2 multiply by 10 to negative 2 divided now by 100, and then when I use my calculator I have 0, 0,00002. Do we have an SI unit for strain? No, we do not have an SI unit. Then this, ladies and gentlemen, becomes an easy 4 marks for each and every one of us to be able to get. But you will not get that provided now you do not understand the English, that now the length also increased by 0,2. Fine. At 532, the stress experienced by the drag, already it will give me now another 1 mark for the formula. Let me do this. K is equals to over this one because the Young modulus of the steel is now 4 multiplied by 10 to power 10. 4 multiplied by 10 to power 10. We want to calculate our strain, and thereof we calculated 0,00002, and then you get your strain now, ladies and gentlemen, as something like 80000 Pascal, because we said it is measured in pascals. So it becomes easy provided that you are able to identify your variables. You are also able to identify the correct SI unit thereof, because this, like I said yesterday, it goes hand in hand with the F sort formula substitution, answer with the correct SI unit, and if it is a vector it must have a direction. So one will lose marks here because of not having the correct SI unit. However, for strain, ladies and gentlemen, we do not have the SI unit. Then 5.4 ask that question to say, explain why strain does not have an SI unit. Ladies and gentlemen, it is just because it is the ratio of the same physical quantity. Ratio of the same physical quantity. So both of them are basically length and just another length. So it's meters divided by meters, so we do not have any SI unit for that. So basically all we are saying is be on the lookout for such questions, be on the lookout to say, but in actual essence the only key calculations here are for strain, stress, as well as the modulus of elasticity. So let's just be on the lookout for that, ladies and gentlemen. When you check, all other things that they can ask here will be basic theory or will be a definition thereof. Ladies and gentlemen, let's go to question 6. Now for question 6, it says state Pascal law. So stating Pascal law is what we did it must give me now that maximum of 2 marks. Calculate now the weight of the patient. Ladies and gentlemen, we said we must apply. We must use the state, the use, and the application thereof. Because it was Pascal law. The only equation that I know that relates with Pascal law is this one of F1 over A1 is equals to F2 over A2. That is the one that I now know. So how best can it be complex for me not to understand that if the definition thereof is a law, immediately thereafter I'm expected to apply that particular law. Let's read the question again. A dentist raises his patient with a chair by applying 4 or 200 newtons to a hydraulic piston with an area of 2 centimeter squared. The chair is attached to a piston with an area of 4 centimeter squared. We do not have a problem. We do not have to worry about conversion. Why? Because my area is in the same SI unit. So I'm just going to say, fine, ladies and gentlemen, if you tend to convert to meters for the sake of us getting the correct SI unit for the force, then it will just be 200 divided by 2 multiplied by 10 to negative 4, which is just equals to F of the patient, and then divided by 4 multiplied by 10 to power negative 4 also, and then you get your F2, ladies and gentlemen, as 400 newtons. Now, state, use, and apply. We said the apply refers now to life scenarios. Therefore, write down 3 practical examples of the hydraulics, except a dentist chair. So we are at 6.3. At A, we can have what we call a hydraulic press. We can also have something like a forklift, that is also a hydraulic forklift. And we can have something like a hydraulic jack. I think the examiners will also accept if you just say forklift or just jack. I think they will accept, but it is always important to understand that we differentiate all this with the weight or the emphasis thereof of the word hydraulics. So ladies and gentlemen, in simple terms, this is one of the sections where each and every one of us should be able to get the maximum marks. Ladies and gentlemen, I said I intend on keeping you here for 45 minutes. I have exactly done that. It is exactly 14:50. I'm going to give you now another 50 seconds for us to digest and maybe take questions if there's any. If there are no questions, then I will do the closing remarks and we will be able to plan for a session of tomorrow. Ladies and gentlemen, I don't see any questions or hands on YouTube as well as our chat. So, with that being said, ladies and gentlemen, thank you very much for your support and thank you very much for your being here. May the great Lord bless you and give you everything that your heart desires and the strength to actually do well on the coming exams. With that being said, let's meet on the next one. Thank you very much and have a lovely day.